Now this unit we're doing dilution and general ventilation, but we're pretty much at the end of what I wanted to cover with regard to the dilution ventilation side of it. So let's go ahead and review, summarize what we've talked about with regard to dilution ventilation. Again, with dilution ventilation, we're diluting the toxins, or we're reducing the flammable vapor concentrations in a space, or we're ensuring that there's adequate oxygen in the space. And those are the three general objectives of dilution ventilation. A lot of the same principles as with local exhaust ventilation. Pressure, velocity, volumetric flow rate, a lot of the same variables are involved. Now, one thing we talked about, in many cases, natural ventilation may be all that's needed. But in other situations, mechanical systems may need to be implemented. But if we have to implement a mechanical system, it may only require one fan set up as a blower, blowing air into the space. But it can also range all the way up to the more complex end, where some of the more complex dilution ventilation systems may start to look a lot like a local exhaust ventilation system. We talked about monitoring the system's effectiveness. We smoke tube testing, look at the velocity, the static pressure. But more importantly, I think, than anything, is once we get our system set up, we need to continue to monitor for harmful conditions in that space. General ventilation. And when we talk about general ventilation, we also have to include a discussion of indoor air quality, because general ventilation is the method by which we maintain good indoor air quality. There is a reading that goes along with this information. It's the OSHA Technical Manual for Indoor Air Quality, and it is available on Blackboard. Please take a look at that material. We need to talk about the differences between dilution versus general ventilation. Now, many safety professionals view them as being one and the same. Dilution ventilation is general ventilation. General ventilation is dilution ventilation. But other safety professionals, and I'm in this group, that view dilution ventilation as focusing on more serious health hazards, while general ventilation is more about comfort and indoor air quality. Now, there is overlap. When you talk about indoor air quality, you can be getting into some areas where there could be serious health hazards. Again, that kind of overlap exists between the two, but generally speaking, I think it's safe to think of dilution as focusing more on the more serious hazards, while the general ventilation, the focus is more on comfort and indoor air quality that's not necessarily a major health hazard to the occupants. Now, general ventilation can be thought of as your HVAC system, your heating, ventilation, air conditioning system. That's basically what it is. It's like the ventilation system in your homes or the air conditioning heating system in a commercial building or warehouse. The components are there, the ductwork, the fans, the air cleaning elements, maybe heating, cooling, or dehumidifying components are included in a general ventilation system. Also, the same principles are at work as are in other ventilation systems. Pressure, velocity, air volume, fan laws are applicable to general ventilation systems. There's a lot of overlap between all of these different ventilation systems. Again, with general ventilation, we're focusing more on comfort, but also on the health side of it, it's indoor air quality. That's an important focus of general ventilation. And I don't want to diminish the importance of general ventilation when I say, well, it's just about comfort, or it's more about comfort. Comfort's very important for safety. The comfort of worker is important. Comfortable workers are going to be more productive, they're going to be safer workers, and they're not going to cause as many problems for management. They're not going to be complaining about it's too cold, it's too hot, the air in here is stale, I can't breathe. You're not going to have those types of nagging complaints from workers. Again, and that's, I don't want to diminish those complaints. Those complaints are important. We need to listen to our workers if they make those kinds of complaints, because we do want them comfortable. We do want them working at the right temperature, working at the right oxygen levels. We want good airflow, good air change, room air change within the space, because that's good for the company. If we take care of the workers will take care of the company. The workers are the most important tool, so their comfort should be important to employers. Now, indoor air quality, it's really kind of a modern problem. Over the years, we've gotten better and better at building structures. We have tighter buildings with tighter envelopes. With a modern building, it's really hard for air to get in and it's really hard for air to get out. We build these buildings so air can't get out, so we can keep all the heated air in and the cool air in. But by building these tighter buildings, we're also making it more difficult for the buildings to breathe. We're making it almost impossible for natural air to infiltrate the building. And prior to the improvements in building technology, a lot of the ventilation, the general ventilation that occurred through openings in the building. There was a natural infiltration of outside air. So with tighter buildings, we've had to be more aware of the potential for indoor air quality problems. In a study conducted by NIOSH, they looked at 500 indoor air quality investigations. They identified the most common sources causing poor indoor air or reducing indoor air quality. Number one, 52% of the 500, over 250 of the investigations, found that inadequate ventilation was the primary source of the quality problems. Contamination from inside the building accounted for 16% of the cases. 10% of the cases, or about 50 of the investigations, there was some kind of contamination from outside the building. Maybe it's sitting next to a dumpster, or maybe it's located next to a stockyards or a feedlot, or maybe it's located next to a sewage treatment plant. When I worked for Manhattan Road and Bridge, the Muskogee office was right across the road from the Muskogee sewage treatment plant. And if the wind was blowing just the right way, you were fine indoors, but you went outside and it wasn't dangerous necessarily, but it was a nuisance. It wasn't a good smell. You didn't really want to spend a lot of time outside when the wind was blowing just right. But again, contamination like that from outside the building, about 10% of the cases. And again, we're just talking about this NIOSH study where they looked at the results of 500 air quality investigations. Microorganisms. In 5% of the cases, microorganisms were involved. If our ventilation systems aren't set up properly, like with Legionnaire's disease, bacteria, viruses can form inside of our ventilation systems and make us sick. And this is an example of, we're talking about general ventilation and indoor air quality and comfort, but it can slide over into the health hazard category as well. And we talk about microorganisms and Legionnaire's disease, for example. Then we're getting over into the health hazard side of it. A good HVAC general ventilation system should help reduce microorganisms that are becoming airborne. And now is certainly a time when we're should be more conscientious about microorganisms in our airstreams. So, and we'll talk a little bit more about this. We'll talk about allergens and biological contaminants and some different ways we can manage those within our buildings. It could be a contamination from building fabric. By building fabric, we're talking about pretty much the textiles in the building, the carpets, the furniture coverings, the wood. The wood flooring would be an example. Off-gassing from these new building materials can put a lot of different contaminants into the air. And speaking of contaminants, let's talk about the types of contaminants that are managed with a general ventilation system. Temperature, of course, humidity, nuisance odors, carbon dioxide, oxygen levels, which we'll talk more about, tobacco smoke. I mean, we're getting away from the age of, in the 60s, everybody smoked. Over the years, fewer and fewer people are smoking. And we'll talk a little bit more about that. I've got some numbers to throw at you. But tobacco smoke is not the indoor air quality issue that it used to be. But where tobacco smoke is present, there are hundreds of toxins that have been identified in tobacco smoke. Off-gassing from building materials. Some examples, paint, carpet, manufactured wood products. One of the most common types of vapors emitted would be vapors from volatile organic compounds. Many different toxins can be involved with off-gassing. There have been some extreme cases where buildings have pretty much been unoccupiable. They've not been able to occupy the building because the off-gassing was so severe. After a major construction job or a major renovation, all of these vapors given off by the new materials made the building dangerous for occupation. Also, depending on the filtration system that we have, we can use our general ventilation system to manage allergens, biological contaminants, and various particulates. And we've talked a lot about HEPA filters this semester. You can have systems set up with HEPA filtration. There are other filtration systems as well that you may be able to use. And we'll talk a little bit more about those later in the module. If you would like to learn a little bit more about all of the different toxins that may contaminate our indoor air, there's material from the EPA that I've uploaded on Blackboard, and we're going to take a look at it in the next slide also, some of the EPA material, but also the OSHA technical manual that I've assigned as a reading will provide more information about other contaminants, other toxins that can be present in indoor air. Okay, well, let's look at some EPA information. Again, sources of indoor air contaminants. Again, this is from the EPA, and they identify several different sources of contaminants. They break it down into a few different categories here, and I might use my pen on this slide. Again, they break it down into outdoor sources, building equipment, components and furnishings, and then they have just kind of a grab bag, potpourri of other potential indoor sources. But outdoor sources, pollen dust, industrial emissions, could be vehicle emissions. Vehicle emissions, when you look at air quality in the United States, the vehicles we drive is the primary polluter, putting nitrous oxides, sulfur oxides of sulfur, carbon monoxide into the air. A lot of our air contamination in the United States is because of all the cars we have on the road. It could be an outside source, could be, again, odors from dumpsters, unsanitary debris or building exhaust near outdoor air intakes. The outdoor source could even be underground. Radon, which is the result of uranium. I think I spelled that right. The decay of uranium produces radon gas. In Oklahoma, radon is not as much of a problem as it is in other areas of the country, but radon gas can be a significant cause of poor indoor air quality, and it can make people sick. Pesticides, leakage from underground tanks, also. As far as the building equipment, it could be problems with your air conditioning system, your heating, ventilation, air conditioning system. Again, we talked about Legionnaires a little bit. Maybe there's something growing in the drip pans. Talking about microorganisms growing and being spewed out into the area through the ductwork. That's something to consider. But more commonly, it's just going to be improper design of the system. The registers aren't in the right locations. The intakes are not the right locations. The fan is not working properly. Something like that. Or it could be as simple as dust or debris in the ductwork. A friend of mine I went to high school with, he has a business in Tulsa. That's what he does. He cleans ductwork. And he'll run a video, or he'll run a robot through the ductwork to show the homeowner all of the debris and crap that's piled up in there. Then once he convinces the homeowner they've got a problem, then he will clean up the ductwork for them. And I've seen some of the videos that he's taken, and there's a lot of crazy stuff that can accumulate in ductwork. There's also some stuff in ductwork that never should have been there in the first place. A worker leaves a glove, or there's a empty spray paint can that's left in the ductwork, which goes back to the building of the structure. And you'll see this occasionally with some builders. They'll get sloppy, their housekeeping is crap, and they'll leave stuff behind that shouldn't be left behind like that. But also, as far as building equipment, it could be like copiers, office equipment, copiers, mimeograph machines. You don't see a lot of mimeograph machines anymore, but the mimeograph machines from the 60s, 70s into the early 80s, there was significant odors given off from that process. Probably more of a nuisance odor, but at certain concentrations could also have health impacts as well. Then we've talked a little bit about this already. Furniture, emissions from new furnishings and floorings. Mold growth is always a concern where you have high humidities. Anywhere you have high humidities, you run the risk of having mold growth. Some mold is fine, is safe. Some mold can be a health hazard for humans. Some humans are going to be more sensitive to the mold than other humans. But again, there's a whole long list of possible sources of indoor air contaminants. Then you go over here to this list. Some of these we've already talked about. Copy, print areas, food prep, smoking, cleaning materials, emissions from garbage, pesticides, paint, chalk, adhesives, occupants with communicable diseases, which is certainly relevant right now, dry erase markers, and again, several more as well. But if you, as a safety manager, if you ever run into a situation where you may have indoor air quality problems, this is a list that you should consider. Now, one recent case, I think goes back to 2016. It's not as recent as it was, but it's still in my mind. But it was formaldehyde off-gassing from manufactured wood products that were sold at lumber liquidators. The product coming from manufacturing facilities in China had more formaldehyde than they should have had. And that formaldehyde was off-gassing, was vaporizing into the buildings where the flooring was laid and causing health problems for the occupants. And that received a lot of attention in 2016. Now, just as a sidebar, if you're building your own home, or if you're involved in the building of a commercial structure, it might be worth looking at building products that are low VOC, that have been identified as green building products or safer building products. You can get low VOC paint. You can get wood products like wood flooring that doesn't have any of the, or as many of the harmful chemicals. So just something to think about. Now, there are a couple of specific illnesses associated with indoor air quality. One of those illnesses is sick building syndrome. Sick building syndrome is a generic condition associated with widespread complaints from building occupants. It can be a number of different symptoms: headache, nausea, respiratory distress, allergic skin reactions. But the frustrating thing about sick building syndrome is that these symptoms are associated with time spent in the building, but we're not able to identify a specific cause. We know it's, people who spend time in that building get sick and have these symptoms, but can't identify it. Is it the carpet? Is it the paint? Is it our ventilation system that's not working properly? It is a mystery illness, but it's a real illness when you have multiple people suffering similar symptoms. It is a real condition. Now, on the flip side, we have building-related illness. Now, these are two separate things. With building-related illness, we're talking about a diagnosed illness that is directly related to the building. Similar types of symptoms may be involved. But with building-related illness, the investigation is able to identify a specific cause or causes. For example, it could be vapors coming from the new carpet. Now, if anyone's interested, I'm not going to require you to read this, but I'm going to put a sick building fact sheet available on Blackboard. This is from the EPA. It's I think it's like 3 pages if I remember correctly. But it's a real concise, informative fact sheet dealing with sick building syndrome, and it also talks about building-related illness.